Welcome to Math Methods question 1 for the calculator free section of the 2025 exam. We are given a continuous random variable with a probability density function shown here with bounds from 1 to 5. The question asks us to calculate the exact value for the mean of x. One thing that should be extremely obvious here is that mean equals expected value. Now, from our formula sheet, we are given a formula for expected value as so. Now, what we need to find is our bounds, which are given here in the question, as well as our px function, which is given here in the question. All we have to do now is sub these values in. We end up with the integral from 1 to 5 of x, 1 over x ln 5 dx. Notice here that you can cross out the x's, and we're able to simplify our function to 1 over ln 5. Note that 1 over ln 5 is a constant, and thus the integral of any constant is just that constant times x. So we'll end up with x over ln of 5 to 1. Then all we have to do is evaluate this function by subbing in our bounds wherever we see an x. Minus 1 over ln 5. And since the question asks us to simplify our answer, we'll just evaluate this expression to get 4 over ln of 5. Now, part B asks us to determine the exact value of the median and defines the median as some point where the probability equals 0.5. To fully understand this question, recall that a probability density function looks something like this, and to find the probability, all we have to do is find the area under the curve. And so we're looking for some point M where the area underneath the curve equals to 0.5 of the total area. Therefore, the probability is 0.5. So how do we do this? Recall that for a continuous random variable, the probability between a set of bounds can be written as the integral between those bounds of the probability density function. Remember that this is how we find the area under the curve normally for regular calculus. So there's no reason it would be different just because we're working with probability. From this part of the question, we can see that our probability needs to equal to 0.5. And then our top bound is going to be m, and our bottom bound is not defined or not stated, so we're just going to assume it's the lower bound. So this gives us 1 to m of px, which is x over ln of 5 dx. Recall that the integral of 1 over x is equal to ln of x. And we can use that to help us find the integral of this function. So we'll end up with ln of x over ln of 5 m to 1. And then doing the exact same technique, every time we see an x, we're going to sub in our value for our bounds. So we get ln of m over ln of 5 equals, minus ln of 1 over ln of 5. Recall that ln of 1 equals 0, and so this entire thing becomes 0 and can be ignored. Finally, this equals 0.5, and we can do some simple rearranging to get the value of m. So ln of m will be 0.55. Recall that our log rule has k log of x is the same as log of x to the power of k. So thus we have ln of m is equal to ln of 5, 0.5. And anything to the power of 0.5 is the same as square root. So you can rewrite it as so. And finally, m is equal to square root of 5 after undoing the ln's. And that is how you do all of question 1.